Hello everyone, this is DEEPAK Joshi, and today we are going to solve another problem statement from LeetCode, that is number of bits. So in this particular problem statement, we have given n, that will be an integer, and what we need to find out is we need to find out the number of set bits available in the binary form of the number. Uh, So what is a set bit? A set bit is nothing but a one that is available in the binary representation. So to understand this better, let's visit Excalibur and try to understand what the things are. For example, we have given the example of 11. Now if I take this pencil, utilize black only. Yeah, yeah. So we have given, I don't know how to do, yeah. So we have given 11. Now this 11 can be represented as, um, if I'm not wrong, 2 raised to the power 0 is 1, then 2 raised to the power, yeah, 1 is 1 again, 2 again, 2 plus 1, 3, and then we need 8. So 0, 1. So this is the binary representation of 11. The total number of uh, set bits that are available, we can count easily, are 3. Okay. So what we need to do here is we need to understand things in a much better way. How? We need to count the total number of set bits that are available. The first approach is convert the integer that we have into a binary number, and then count a, a number of what we call set bits, right? This is the one approach that is available, and it is pretty straightforward. I'll not go into this. It seems pretty easy, but the second approach that we have is something, is some sort of interesting. So we had 11, that is 1 0 1 1. Now if we talk about the right shift operator, what is a right shift operator? Right shift, let's understand right shift operator in much more depth. I think I'm just going in a very vertically inclined manner, but that's fine. So the value of 2 is 0 1 0. Okay, if I do right shift on 2, that will means shift the numbers to right, shift the bit by 1, so it is 0 0 1. So right, this operation resulted in this set bit, right? Let's take another example. Let's talk about 5. So we have 5. 5 will be uh, 4 plus 1, right? 1 0 1, if I'm not wrong. Then if I'll apply 5 right up, shift, let's say 2, like I want to shift it by 2 bits. In that case, it will be, I need to shift 1 0 1 1 by 2, so it will be 0 0 1. So the value of this operation 5 right shift 2 will be 1, because 0 0 1 is nothing but 1. So there is very interesting thing. There are total, how many total number of bits are available? uh like one, like integer contain uh 32 bits, right? So there will be 4 bytes, and then 1 byte contains 32 bits. So overall there are 32 bits available. So if I'll do the right shift approach and check the last one, for example, let's start with 5. We had this 5 as 101. So I'll start with 101, check this last integer is 1. I'll plus 1 the counter. Okay, the count that will have, and then I'll get rid of it, so it will become 1 0. Now I'll check, will is it a 1? No, so I'll not increment it next time. I'll do a right shift on this, and in that case 1 will be remaining. So it is it a 1? Yes, so I'll do a plus 1. That makes sense. And then I'll do a right shift and nothing will be remaining. Like there will be 0 0 0 remaining, a lot of zeros. So what I can do is I can also check the form. If the number becomes 0 itself, then no need to check. Okay. This is the whole operation, but to make it much cleaner or clear, let's do one more thing. Let me just check whether I have started recording or not. Yeah, I think I have started. Because most of the yeah. Let's check for 11 then. Okay, let's do for 11. It will be 10. I think I made a mistake. 1011. So it will be 000 la 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 1011. We'll start with the first number will count plus one. Okay, and then we'll do right shift 00 dot 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 101. Additional zero will be added here, right? And then we'll check the last number. Yeah, plus one. Okay, and then we'll do the right shift and dot 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 10. Nothing to be added. Then 0000 dot 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 1 remaining, because that 0 is added here, so it is a 1 plus 1. And then next all will be 0. This whole number will be 0, right, in decimal numbers, in integer formats. So we have this clarity now. Now we'll go to our number of bits and let's talk about this. How will we plan to implement this thing? It's pretty easy. What we'll do is we have will initialize int with 0, like int counter with 0, because uh, it's something that we are going to count. Now what we need to do is we need to iterate all the iterate till the number becomes 0. So we'll iterate n is not equal to 0. We'll do this, and so my screen is here. I'm just looking here for now. If uh, uh, yeah, this is something interesting. I'm doing an OR operation. Instead of how do you check the last number is 1 or not? So what I am going to check is simple. Just check the last number. Simple. Check because anyhow 1 and 1 will become 1 if 0 and 1 will be 0. Okay, 0 and 0 will be 0. Okay, and 0 and 0 will be also equal to 0. So this is the only case when it will be 1. So that is what I'm going to check. If n ampersand or n and 1 becomes 1, that means true. So in that case we'll be implementing the counter, right? uh, Now we have to get rid of the last number that we have just calculated, so we'll be doing a right shift, that is n. Yeah, that is how we do right shift, and I think we'll return just the counter. This is mostly what we need to do. Let's submit it and see if it runs as expected or not. Seems like all the test cases passed. Now let's submit this one. Yeah, it got submitted, like the 100% thing. Hopefully we were able to explain this problem statement. See you in some other video. Bye bye.